Good morning, students. Welcome to the session. In the previous sessions, we have discussed about combination logic circuits, how to design combination logic circuits, what is meant by combination logic circuits, what are the steps required to design combination logic circuit. And in this regard, we have seen some designs of adders, multiplexers, and decoders. Today, let us discuss about sequential logic circuits. What is meant by sequential logic circuit? Already at the beginning of this unit, I have told you the meaning of sequential logic circuit, and also I have given some differences between combination logic circuits and sequential logic circuit. So in combination logic circuits, the output of the circuit depends only on the applied inputs, right? Whereas in case of sequential logic circuit, the output of the circuit not only depends on the applied inputs but also on the past outputs, right? So we require a storage element in case of sequential logic circuits. There is no storage element required in case of combination logic circuit because there is no past output in case of combination logic circuits, right? When compared to combination logic circuits and sequential logic circuits, design of combination logic circuit is easy, whereas design of sequential logic circuit is difficult. And if you compare these two circuits in terms of its operation, combination logic circuit are faster in operation, sequential logic circuits are slow when compared to combination logic circuits and sequential logic circuits. Let us see first of all what is meant by sequential logic circuit. Sequential logic circuit. Right, this is the block diagram of sequential logic circuit. This is the input you are applying inputs, and this is the output. This output depends on the applied inputs as well as the past output. So we don't know what is the past output. So in order to store the past output, we require a storage element or memory element. Memory is nothing but storage. Memory element, right? So this is the block diagram of sequential logic. Right? The output of the circuit or system depends on the applied inputs as well as the past outputs. In order to store the past output, we require a storage element, that is memory element. It is connected in feedback to this combination logic circuit, right? So this is sequential logic circuit. So in case of combination logic circuit, you have only so this is combination logic circuit. Right? And next, output. This output depends only on the applied inputs, right? As this output depends only on the applied inputs, there is no past history of data. There is no storage element, right? Only this output depends on the applied inputs, present input variables. This output depends on the present input variables, applied input variables. Whereas in sequential logic circuit, this output depends on the present input variables as well as the past output. So in order to store the past output, we require a memory element, this one. This is the block diagram of sequential logic circuit. This is the block diagram of combination logic circuit. So let us see what are the differences between combination logic circuits and sequential logic circuits. Differences between combinational and sequential logic circuits. Very important question. Either for 2 marks or 5 marks. Very important question. So first one, I will take combinational logic circuits. This is sequential logic circuits. First, in case of what is it? Write the definition. In combination logic circuit, the output depends only on the present input variables, whereas in sequential logic circuits, the output depends on the present input variables as well as on the past outputs. So to store past outputs, memory element is needed. That is the first point. Second point, right? So there is no storage element in combinational logic circuit. There is no storage element in combinational logic circuits, or storage elements are not required in combinational logic circuits. Memory elements, there is no storage or memory element. In case of sequential logic circuit, to store the past outputs or past history, memory elements are needed, right? Next, as the delay in combination logic circuit depends only on the, as the output depends only on the present input variable, so the delay is between the input variables and the output, right? So the delay is less. Delay is less. What is the delay? Propagation delay. Propagation delay is less. As the delay involved in sequential logic circuit is the delay required to switch the variables from input to the output through memory elements. So propagation delay is more, right? Next, as delay is less, these are faster in operation. As the delay is more, slower in operation compared to combinational logic circuits. Right? Next one. These combinational logic circuits are easier to design and these are difficult to design compared to combinational circuits. Right? The examples, next one. Examples are parallel adders, multiplexers, decoders, etc. Examples in this case are latches, flip-flops, shift registers, counters, etc. Right? So let us see all the differences one by one. First of all, the combinational logic circuits. In combinational logic circuits, the output of the system depends only on the applied inputs. In case of sequential logic circuits, the output depends on the applied inputs as well as the past outputs. So there is no storage element required in case of combination logic circuits. There is no past output, so there is no storage element. In case of sequential logic circuits, in order to store the past history of data or past output, we require a storage element, right? And here, as there is no storage element in case of combination logic circuit, the propagation delay is the delay in between the input variables to the output, right? So the delay is less. In case of sequential logic circuits, the propagation delay involved is between the input variables and the output through the past history or past output. So the propagation delay is more. In case of combination logic circuit, as the propagation delay is less, these circuits are faster in operation. As the propagation delay in case of sequential logic circuit is more, these are slower in operation. So these combination logic circuits are easier to design because there is no storage element, and these are difficult to design when compared to combination logic circuits. The examples of combination logic circuits are parallel adders, multiplexers, decoders, encoders, comparators, parity bit generators, code converters, etc. And examples of sequential logic circuits are latches, flip-flops, shift registers, counters. All these are the examples of sequential logic circuits, right? Let us see what are the types of sequential logic circuits we have. How many types of sequential logic circuits are present? So there are two types of sequential logic circuits. One is synchronous, second one is asynchronous. What is mean by synchronous sequential logic circuit and what is mean by asynchronous sequential logic circuit? So the sequential logic circuits are categorized into two types. They are synchronous sequential logic circuits and asynchronous sequential logic circuits. So what is mean by synchronous sequential logic circuit? What is mean by asynchronous sequential logic circuit? As sequential logic circuit is the circuit in which the output depends on the present input variables and the past outputs. So in case of synchronous sequential logic circuits, the output will be affected whenever the input variables are changing and also upon the activation of a clock pulse, right? In case of asynchronous sequential logic circuit, the output will be affected when input variables are changed, right? At any instant of time, if there is a variation in the input variables, there will be a variation in the output, right? At an instant of time, depending upon the activation of the clock pulse, if the input variable changes, there will be change in the output variables, right? In the meaning of synchronous sequential logic circuit is there is a gating signal, there is a control signal called as clock. In case of synchronous sequential logic circuits, clock signal is available. In case of asynchronous, no clock signal is available. So with the presence of clock pulse, upon the activation of the clock pulse, the output will be affected for the changes in the input variables. As there is no clock pulse, in the absence of the clock pulse, at any instant of time, the output will be affected by varying the input variables. If there is a change in the input variables, the output will be affected at any instant of time. Here we have a clock pulse. Depending on the activation of the clock pulse, the output is affected by varying the input variables. So the input variables have to synchronize with the clock pulse. In this case, there is no synchronization for the input variables in case of asynchronous sequential logic circuits, right? So in synchronous sequential logic circuit, depending on the activation of the clock pulse, input variables will synchronize with the clock pulse, and based on the change in the input variables, the output will be affected only when the clock pulse is on, when the clock pulse is applied. Here, as there is no clock pulse, the output can be affected at any instant of time if there is a change in the input variable, right? Clock pulse is available in this, no clock signal is available in case of asynchronous sequential logic circuits. If you look at the differences, the output will be affected depending on the activation of clock signal by varying The output will be affected only on the activation of the clock signal by varying input variables. As there is no clock signal, the output will be affected at any instant of time if the input variables are varied or changes. Next one. So as there is no clock pulse involved in asynchronous sequential logic circuits, so the delay involved will be less when compared to synchronous sequential logic circuits. So these are faster in operation, these are slower in operation. Next, these are easier to design, these are difficult to design. Examples are synchronous counters, flip-flops, synchronous counters, etc. Shift registers also come under this category. And the examples are latches, asynchronous counters. Right? These are the differences of synchronous and asynchronous sequential logic circuit. Let us see one by one. First, synchronous sequential logic circuits. As the clock pulse is available in case of a synchronous sequential logic circuit, the input variables have to be synchronized and there will be effect in the output. Whenever the clock pulse is activated, depending on the activation of the clock pulse, and by varying the input variables, only the output gets affected. In case of asynchronous sequential logic circuit, the output will be affected at any instant of time by varying the input variables, as there is no clock pulse in case of asynchronous sequential logic circuit. And in the absence of the clock pulse, the delay involved is in between the input and output, so these are faster in operation. As the delay involved is in between input variables and the clock pulse, so these are slower when compared to this. And these are easier to design. Synchronous sequential logic circuits are easier to design, and these are difficult to design. The examples are flip-flops, synchronous counters, etc., latches, asynchronous counters, etc. So these are the differences between synchronous and asynchronous sequential logic.